class, today we are doing the Chapter 8 final review. We're going to be translating from word problems to algebraic equations. So the first thing that we know is we'll see these words: is equal to, is the same as, is, gives, was, will be. These are all words for equal. If you see any of those words in a problem, it means equal. We're used to this. Is equal to means equal. Is the same as, we know that means equal. Is, we've gone over is several times meaning equal, and we've also seen it with is over of, with fractions, which are still dealing with fraction ratios, all of that stuff. So all of these words mean equals. But let's look at other words in problems and see if we can determine how to solve them. So here's an example that it's been given us, okay? So we're translating the sentence from, it's this: the sum of 6 and 9 is 15. So it asks us to bring it up. The first thing that it does is it finds that is, like they say, and it turns it into an equal sign. So now we have the words, the sum of 6 and 9 equals 15. Awesome. Then we have to figure out the words sum and those mean addition. So with sum and meaning addition, we know that we're going to be adding 6 and 9 to equal something, which we already know it is 15. So that's exactly how you would go about doing this problem right here. So that's how we would do that problem. Let's look at this problem. So let's start here. The sum of 3 and 7 gives 10. I think it's a weird phrasing. They're saying gives, they're saying that, but they're trying to introduce us to other words. So what would that be algebraically? If we wrote that in an equation, what would that look like? Excellent. So as you guys wrote, it is 3 plus 7 equals 10. And we all know we're smarty pantses. Yes, that is correct. So let's try these two with different words. So we'll look at this first one up here, okay? It says the product of 8 and 7 is 56. So here we have our is. Our is means equals. Then we need to know what these other words mean. We see that word product. Product. So what does product mean? Who can tell me? Excellent. Product means multiply. Someone said times. Someone put that little X for multiplying. Yes. So it means multiply. So when we see this, we're multiplying. So for that top problem right there, as you guys wrote, actually, it is 8 times 7 equals 56. Exactly. So the bottom one, as somebody else wrote from earlier, and we saw that, is 3 times 4 equals 12. Look at this. You guys are rocking it. And so far, hey, those all make sense. We all know those. That's great. That's a great answer. So what happens when we go to our next problem? Now we have something new that we've introduced. What did we introduce to this that's different from the last ones? So what's new? Yes, Fernando, we introduced a variable. So now we've got here in X, here in R. Remember, variables can be anything. An example of a variable. So if we had this, examples of variables. Our most common ones are X and Y. We've also got common ones being A, B, C. We've got some common ones being N, M. We've got ones where they can technically use a star, a heart, a smiley face, a chicken. So any sort of thing can technically be a variable. Now, if you remember my pirate joke, what do mathematicians and pirates have in common? We're always searching for the X, ha, ha, ha. Yeah, that's because we typically use X, but it can be anything. So, Translate the sentence into an algebraic equation. Twice the difference of x and 3 gives 18. So gives, like I said, even though I don't like it, that's one of our equal words. So we know it's equals 18. Right there. We're just going along, following it basically from left to right. This is here, this is after it, so it just follows suit. Gives 18 equals 18. Twice the difference. What does twice mean? When I see the word twice, what am I doing? It has something to do with 2. I'll give you a hint. But what am I doing with that 2? Am I adding, subtracting, multiplying, or dividing that 2 when it says twice? Yes, you guys, I am multiplying it. So twice the, which means times, multiply by 2. Twice means times 2. Twice the, then we're going to break this up. Difference of x and 3. Notice how that's all one complete section right there. That's all one complete section, the difference of x and 3. It's saying difference of, and then we still include the and. So all of those go together. What does the difference of x and 3 look like? What does it mean either in words or what does it look like? Exactly, when you guys did it, Michelle, Ani, Hannah, we got that. It is x minus 3. So we bring that down. Difference means subtraction. So difference means subtraction. And like I said, just like how it's in its own box up here, it's in its own parentheses down here. So this x minus 3, it's in its own parentheses because it's its own bit. So there we go. Now we've written it out as a word problem, or as from a word problem to an algebraic expression. But now what do I do? Am I done now? So I had one of my students saying, oh, that's not an x, it's a z. But does it matter? What if it was an a? Does it matter? No. As long as you keep the variable in the same place, as long as the variable means the same thing, it could be any variable you so chose. You might not always be given an x. You might not be told what your variable is. And you get to make up one for yourself. There is no wrong variable to use as long as it's a variable. So here though, like I want to say, what do I do now? I know that we have to do this. Yes, I got someone. I'm so happy. Yes, Izzy says we isolate the variable and solve. Yes. Right now, what's technically isolated is this 18. It's over there all by itself. But we want the x at the very end to be all by itself. I'm going to put it right here at the bottom. X equals. Doesn't matter what side your x is on. It could be equals x. Think 5 equals x equals 5. Same exact thing. I just like to keep it either on the left-hand side and or whatever side it is already on. Since it's already on the left, cool, keep it on the left. So now we gotta isolate the variable. Awesome, you guys. But what do I need to do to isolate this variable? What do I need to do to isolate this variable? So for example, what I'm asking is, what's the first step? What's my first step? Here I've got 2 times, in parentheses, x minus 3, end parentheses, equal 18. So, we normally do this. So I got Izzy who says add 3. That's a great idea. But in this weird case, this is when it's actually in a different order. Exactly, we divide by 2. When we are solving for variables, we use reverse PEMDAS, or as I like to call it, SADMEP. I like to call it SADMEP. We do reverse PEMDAS. So the first things we do are subtraction or addition. Exactly what Izzy wanted us to do. But that's inside the parentheses. And the parentheses is all the way back there. We gotta wait until the very end to get there. So only outside the parenthesis. I know how weird this is because it's reverse what we did. So then we do the division and multiplication. There we go. There's this multiplication happening outside the parentheses, so we can do it. It's being multiplied by 2, so what we do is we divide each side by 2. Divide by 2 equals divide by 2. Do you see how I showed my work? Another way I could do it is divide by 2, divide by 2. I draw those lines because I'm making it into a fraction, but it's that same thing. You show your work. Divide by 2, divide by 2. Here, those 2's cancel. 2 divided by 2 is 1. So having 1 of something, we don't need to write 1. We don't need to write it. I have 1 Isabella. I have 1 Michelle. I could just say I have Isabella in my class. I have Michelle in my class. I don't need to specify. I have 1 of them. So now I'm left with x minus 3 equals 18. Are these parentheses important anymore? No. The parentheses don't matter because these parentheses aren't protecting it from anything else on the outside. I like to think of it as like a Band-Aid, but there's nothing else that it could harm it by. So now I go back and I do what Izzy said in the beginning. Since this is x minus 3, we want to cancel that out. Oops, and I made this 18. I have to actually do the work, Miss Diaz. It becomes 9. So then we do what Izzy said in the beginning. It's x minus 3. So I'm going to do plus 3 to both sides. Again, that's how I show my work. Plus 3 equals plus 3. That is real. That is math. That is legal. And again, what's negative 3 plus 3? Or if it's easier to think about it, what's 3 minus 3? Oh yes, that is 0. It goes away. X plus or minus 0. Exactly, you guys, it goes away. So now I just have that x left on that one side. Hey, it's isolated. And now I just solve, where 9 plus 3 is 12. And now let's say I want to go check, right? I want to check my work. I want to make sure, Ms. Diaz, I make mistakes. I want to make sure. So I'm going to put 2 times, and then I've got 12 minus 3 equals 18. We follow PEMDAS here. When there's no variable, you follow PEMDAS. When there is a variable and you're trying to isolate the variable, we're doing the opposite. So we're doing SADMAP. So here, 12 minus 3 is 9. Times 2 is 18. 18 equals 18. Woo! We got it right, you guys. We did it. So then, let's do the same for this bottom problem down here. Okay? So for this bottom problem, it says 4 times the difference of R and 2 give 40. 4 times the difference of R and 2 give 40. So let's break that up. First of all, we see gives. That's their equal word. So now we know it's going to be something, something, we'll put it up at the top here, equals 40. Perfect. So now we've eliminated that part, and I'm going to cross it out of our words. Because look, we already dealt with it. 4 times, hey, that already tells us exactly what we're doing. We're doing 4 times something. Now we're doing 4 times the difference of R and 2. As we did that before, that's R minus 2, because difference means subtraction. Excellent. So we'd go about solving this the exact same way. So what do we get as our answer? I want you to solve it on your own and then tell me your answer. So I got Izzy, Michelle, Ani, and Carmen all told me that the answer is 12. Let's check. So again, there's a variable, which means I'm following SADMAP. Parentheses all the way here, so I have to ignore that one for last. R minus 2 equals 40. So I gotta save that. Here, subtraction, addition, I don't have any of that yet. Division, multiplication, ooh, I have that right here. It's times 4, so I'm gonna do the opposite, right? To get rid of something, I'm gonna do the opposite. So over here, I'm going to divide each side by 4. Divide each side by 4 is equal to divide each side by 4. Excellent. 4 divided by 4, that's gone. 40 divided by 4 gives me 10. Now again, those parentheses don't matter anymore. It's not protecting them from anything in the outside world. They grew up so fast. And then we're still now following that sad met. Parentheses is now gone. R minus 2 plus 2 equals, I like to line it up with my equal sign actually, equals plus 2. Negative 2 plus 2 goes away. 2 minus 2 goes away. So we're left with R equals 10 plus 2 is 12. Excellent. Emmett also got that too, so awesome, you guys. Let's see this next one. Let's look at this problem. 2 times the sum of P and 8 gives 31. So, once again, we look to break it up, okay? Gives 31 means equals 31. 2 times. 2 times. Then we've got this. We have the sum of P and 8. What is the sum of P and 8? Now, whenever we see the word the, by the way, whenever we're seeing 2 different things, we automatically know those things are going to be in parentheses because those are different. So those 2 times the is going to be in its own little kind of parentheses section right there because we have to deal with that first, in a sense. So what does the sum of P and 8 look like? What does sum mean? What does it look like? Who can tell me? What is sum? So Michelle says it's P plus 8. Anybody else have anything to add? Hannah says the same thing. Exactly. Yes. Sum means addition. So sum of P and 8. Awesome. It's a terrible looking 8, but... And then we just go and we do the same things we've been doing before. Still, this is 2 times. So I'm going to do divide by 2 on each side. Divide by 2 equals divide by 2. That's gone. I now get P plus 8 equals, fine, 15.5 for some reason. 15.5 because these people gave whatever. And then we keep going. And now I want to isolate that P, so I'm going to take away 8 because this is plus 8, so I do the opposite. Minus 8 equals minus 8. Those 8s go away. P is equal to, and then 15.5 minus 8 is 7.5, or 7.5, 7 5/10, 7 and all that jazz. Awesomeness. Why it's that answer, I don't know, but whatever. They're not being nice to us. Let's do this one together. 3 more than x is equal to 47. It's a pretty straightforward one. So I want you to do this. Write it and don't hit enter yet, but I'll tell you when. Excellent. So I got people who wrote, in fact, everybody, Izzy, Nathan, Michelle, Emmett, Hannah, and Ani all wrote 3 plus x equals 47. Every single one of them wrote that. Great job. What about this one? Is that correct? What do we think? Is this correct? Yes or no? So I got 1 no and 1 yes. I got a second no. Got a second yes. I got a third yes. Let's see, where are we at? I get a 4th yes, although Fernando agrees that both are correct. Yes, so I got a 5th yes. The answer, Nathan says yes. Yes, they are correct. Now, this only works when it's addition multiplication. Remember, 3 times 4 equals 12 is the same as 4 times 3 equals 12. Fact families! 3 plus 2 equals 5 is the same as 2 plus 3 equals 5. Fact families! But had it been a minus, let's say this problem was this. 3 minus x equals 47, which does work. Yes, x is just negative 50. Maybe. I don't know. If we have this, then we cannot switch it. It cannot be switched to that. No, that does not work. But this problem does work. And then we just do simple solution. We show our work. Yes, we do know what the answer is. I don't just want you to write x equals the answer. I want us to show our work. Here, this is a plus x, this is a 3, this is a 47. I box around the operation in front of the number 2. The operation in front of the number or variable. That's a positive 3. So I'm going to take away 3 from both sides. That 3 is gone. 47 minus 3 gives us 44. X equals 44. If you did not show your work on this, you would not be correct. This one I'm going through quickly again. We're going to do this. Is equal to 22 equals 22. 10 more than x. 10 plus x. Or if you wanted, x plus 10. Same exact thing. They are the same exact thing. So don't ever be worried about those. Those are the same exact thing. Go back and check your work when you do it. Now, that's a positive 10, so I'm going to subtract 10 from each side. Gone. X equals 12. Great job, class. Let's try this one. Okay. The difference of y and 14 is 18. So as we know, difference means subtraction means equals. When you have this, that means these are in their own little section. Those follow that. Write this down, the equation form for this, the equation form. So my 3 lovely ladies who participate. Oh, and Emmett came in clutch. Here we got that. We got Hannah, Izzy, Michelle, and Emmett, Ani, who are, our top 5 participants typically. Come on, guys, we want more. Say, y minus 14 equals 18. Excellent. I want to isolate my variable. I need to get it down to y equals. What is standing in the way between the y and the equal sign? Literally, what is standing in the way? All I care about is that y and the equal sign. All I care about is this y and the equal sign. What's in the way? Some of you are saying 14. But what kind of 14? Oh, there we go. As soon as I said that, Hannah knew. Negative 14. Yes. That's something. And I know you guys were probably thinking on your own, of course I meant that. Yes, but it's easy to miss. So we have to pay attention. What's standing in the way is this negative 14. So how do I get rid of a negative 14? How do I get rid of a negative 14? What do I do? Excellent. Yes, Izzy, Michelle, Caesar, Hannah, we add, as I'm adding with the wrong color, we add 14 to each side once again. Notice, I put it on each side. Plus 14 equals plus 14. Ani did it too. Those two, the negative 14 and the positive 14, they cancel out. Look, now there is nothing standing between our y and our equal sign. And then we add 18 plus 14 gives us 32. There we go. So y equals 32. So for the last practice problem we're going to do together, 7 less than x is equal to 35. Okay, 7 less than x is equal to 35. We already know this part. Is equal to 35 equals 35. So that part is gone. Now I've got 7 less than x. So I have, so far, every single person has written 7 minus x equals 35. So far, every single person has written that for me. All of my typical top reporters and more have written that. Anybody else have anything? And then we hit a new wave right there, where some people wrote x minus 7 equals 35. So, those are the 2 options. Those are pretty much the only 2 options we have. Which one's correct? What do we vote? Do we think A is correct? Or do we think B is correct? What do we think? Let's take a vote. The answer is B. The answer is B. A is not correct for one reason. We see a very, very important word. Who can tell me that key word we see? Yes. Than. We see that word than. Than means it comes after. Funny enough, in English, than with an A is comparison. I would rather be in math class than in history class. Who knows? Then, but in this case, the than with an E in English means after. I want to go to math class, then the park. In math, than at all just means after. Melanie says, I thought it was less than. Less is applicable there, yes. It could be more than. If it said 7 more than, it could technically be x plus 7. But as we went before, 7 plus x and s plus 7 are the same exact thing. So we care about that than. We care about that less than if it helps you. We care about that. So 7 less than x, which means 7 less than x, right there, equals 35. So it is not this top one. Excellent. So now we've got that, and it's time to solve our problem. So remember that. That one's the trickiest one that we have. X minus 7 equals 35. I add 7 to both sides because that's the step we do. Cancel out those 7s because that was the only thing standing in the way between my x and my equal sign. That right there, that negative 7. 35 plus 7 gets me 42. There we go. The answer to life, the universe, and everything. 42.